In this video, we'll be discussing soil pH. Soil pH is complex. It is comprised of multiple classes of acidity: active acidity, salt-replaced acidity, and residual acidity. Active acidity is the hydrogen and aluminum found in the solution surrounding each soil particle. This is the acidity that is measured when we use a pH meter and a soil and water mixture. Salt-replaced acidity is the hydrogen and aluminum bound in easily exchangeable forms to the soil particles. We can measure this acidity when we mix soil with a salt like potassium chloride. When we add potassium chloride, the potassium replaces the exchangeable forms of hydrogen and aluminum on the soil particle. This exchangeable hydrogen and aluminum moves into the soil solution where we can measure it. Residual acidity is the hydrogen and aluminum bound in non-exchangeable forms on the soil particles. These non-exchangeable forms of hydrogen and aluminum aren't replaced easily by salts, and special buffers need to be used to move them into solution. This acidity is not measured with soil and water pH. In parts 1 and 2 of this laboratory, we'll be demonstrating active acidity and salt-replaced acidity. To demonstrate active acidity, we'll mix 1 part soil with 1 part water. We can use a 10-gram scoop rather than weighing the soil on a scale. 20 grams of soil goes into the beaker along with 20 milliliters of water. We stir the solution and allow it to sit for 10 minutes. To demonstrate salt-replaced acidity, we mix 1 part soil with 1 part 2 molar potassium chloride. 20 grams of soil goes into the beaker with 20 milliliters of potassium chloride. Again, we stir the solution and allow it to sit for 10 minutes. When using the pH meter, it's important not to place the pH probe directly in the sediment. Instead, keep the bulb of the probe in the solution and above the sediment. Make sure the pH probe is clean. Wipe the outside of the probe, but not the bulb. Then place the probe into the solution, keeping the bulb out of the sediment. It may take several minutes before the pH reading is stable. After 5 minutes, the pH of our soil and water mixture is 6.01. This is our active acidity. After cleaning the pH probe, we measure the pH of the soil and potassium chloride solution. After the reading stabilizes, the pH of our soil and potassium chloride solution is 5.88. This is our salt-replaced acidity. In our demonstration, the soil and water pH measured 6.01, and the soil and potassium chloride pH measured 5.88. Despite using the same soil, the pH was very different between the soil and water solution and the soil and salt solution. The soil and water pH only measures the active acidity, the acidity in the soil solution. The soil and potassium chloride pH measures the acidity forced into the soil solution by the potassium replacing the exchangeable acidity on the soil particle.